Okay, guys, I think we can start now. Good afternoon, everybody. Let's start. So first, I'm going to make very quick revision on what I did last time before I continue. So here, as I told you last time, guys, any command or any instruction I'm going to teach, it should tell two things. It should tell the operation, and also it has to tell operands. Okay. For the operands, I told you if they can be register, they can be memory location, or they can be immediate value. Okay. So, for example, if I want to do something like that, I want to add register A, the content of register A plus number 20. When you mean number 20, that's what we call immediate value. Okay. And then I'm going to store the result in register A. So it can be register, it can be immediate value, right? So I'm going to take whatever in A, I'm going to add 20, and then the result is going to go to A, right? Also, it can be memory location. For example, here in this example, I want to add a byte at memory location 1000. So I'm going to get a byte from location, whatever is there, whatever is stored in the memory location number 1000. I'm going to get this byte. I'm going to add 20, and then I'm going to store the result in a register. So again, any command should tell the operands. The operands can be register, it can be immediate value, it can be memory location. Is that right? I already explained before. If it is immediate value, what can I do? If you mean immediate value, you have to put hashtag here. So once you see hashtag here, like this one here, that means this is immediate value. This number 20. This is not a memory location. It's not a register. This is number 20. For example, this is this instruction, load instruction. So this one is going to load 20. Load here means store 20 in register A. Okay. So hashtag means immediate value. Is that okay? Any question now? Okay. Now, what if your operand is a register? How can you express this? Okay. If it is a register, as I mentioned, you have to use the letter of the register. Okay. For example, as I'm going to teach later, we have an instruction, we call it transfer. This transfer, you actually copy one register to another register. You copy. So in this case, I can say transfer A, comma B. That means you are going to copy register B to register A. This instruction is actually equivalent to B is equal to A, right? Okay, in C language. Again, don't be confused. We don't have this equal in assembly. Okay. Instead, if you want to do something like that in assembly, you have to use instruction. That's why we have here transfer instruction. So the conclusion is, okay, guys, you have one of three things for operand. It can be immediate value. So you have to use hashtag. It can be a register. You have to use the letter of the register. Okay. Number three, if it is memory. Okay. For memory, so there are actually several formats for memory. That's what I'm gonna explain now. Okay. So okay, guys. So what I want to say, first of all, for memory. For example, you have here 3A F2, for example, okay? And this is memory location 7000, and this is 7001, okay, guys? So if I want to read a location in memory, or if I want to write a location in the memory, all what you have to do, you have to give me address. That's it. Is that okay? So for example, if I want to read a byte at location 7000, okay, you need to tell me 7000, please read the byte at location 7000. In this case, I'm going to read 3A. Okay, that's fine. Also, you can tell me I want to read a word at 7000. So if you tell me I want to read a word at 1,000, 7,000, that means I'm gonna take 7,000 and 7,001, next one directly, okay? So I'm gonna read 3A F2. Is that okay? Same thing if you wanna write. If I wanna write to a byte at, you can tell me, please write a byte at 1,000. So I'm gonna write here. Or I can write a word at 1,000. So in this case, I'm gonna write here in these two locations. Is that okay, guys? So how can you know? So what I want to say here, in both cases, just you give me one address, 7,000. If you want to read a byte or word, you just give me one address. Yes, because you can know if this is byte or a word from the instruction itself. And as I told you, every time I teach an instruction, I'm going to tell you this instruction for byte or a word. For example, load accumulator A, 7,000. So this instruction is going to read a byte at 7,000. When I say load X, 7,000. So this instruction is going to read the word. So this one is going to read a byte. This one is going to read a word. So the conclusion is, number one, if you are reading or writing to a byte or a word, I need address. You need to give me only one address. Is that okay? This, number two, if you want to read a byte or a word, I can know from the instruction itself. Is that okay? Okay. So now, so for memory, if I want to read or write for, so if you have a memory operand, so you have to give me address. Yes, I need address, right? To read or write. Yes, you need to give me the address. How you can give me this address? There are different ways. One way, I explained last time, we call it direct or extended. This is one way, okay? You can just put the address like 1,000, just give me the address, okay? 1,000, so for example, I can say load accumulator register A, 1,000. So this address, you already give me the address, right? So I can just read a byte at 1,000. Is that right? So that's what we call the direct or extended mode. We have another way. We call it indexed. And the indexed here means you are using a pointer. Okay, similar to the pointer used in C language, the same idea. And when I say a pointer, as you will learn right today, we use pointers usually when you want to read or write array. So pointer usually it is used if you read or write array. So what do you mean by a pointer? What I mean by a pointer is I'm gonna have like a register, like for example, register X. For example, I'm gonna like PC. If you remember, PC was a pointer, right? Because PC was storing when I explained it. PC is storing. Is pointing at a location, right? The instruction, same thing here, okay? So I'm gonna use a register, for example, like X or Y as pointers. What this means? It means what I'm gonna store inside X or Y is address. You got what I'm saying, guys? This is how it is. So what, again, can you clarify it? Yes, I'm gonna clarify it. Look at the idea. You have array. This is an array. In this array, you have element 0, you have element 1, element 2, element 3, and so on. Is that okay? Here, this one has address. Is that okay? So the idea is that I have X. I want to scan this array. So I want to read all of them. In the very beginning, you have to put the beginning address. Let's have a number, so just to make it easy. For example, if this is array of bytes, so if this is 1,000, so this one should be 1,001. This one should be 1,002, and this one should be 1,003. So what's going to happen if I want to read this array element by element? What's going to happen? I'm going to get the beginning address. This is the first address. I'm going to store it here in X. It's number 1. So now X is pointing here in the very beginning. X is pointing here. Is that okay? And then I'm going to read the byte pointed by X, which is this one. Okay, so X itself is storing an address. Okay, is pointing at a location. And then I'm gonna read the byte point by x. That's true. So now I got the first element. Then I have to increment x. So x should equal x plus 1. So that now x is pointing here. Then I'm gonna read the byte pointed by x. That's true. Okay. And then I'm gonna increment x so that x is pointing here. And so this is how we can. This is you should understand the concept, the idea of pointers. So pointer mean you have a variable, you have a register, whatever it is. This register is storing address, okay? And it is used if you want to read array. We almost did the same thing for BC. So in BC, you can see your program like an array. Your program, yes, your program is like an array. And every instruction is going to be one element. Yes. And BC was here to read this instruction. And then I increment BC to be here to read next instruction. So it's the same thing we are going to do here for arrays. Okay. So now, for pointer here, guys, we have three ways here. Okay. I'm going to explain them today. One way is you can put constant value comma x. For example, you can say 0 comma x, 1 comma x, and so on. You can do something like that. What it means or how can you get the address, I'm going to explain. The other way, you can put register A, B, or D, comma, and then you can put X or Y. So for example, it can be A, comma, X. I'm going to give you more details. For now, I just want to show you the big picture, okay? And then here, you have a constant and then X or Y, but you have to put plus or minus before or after. For example, I can say 1 comma X plus or 1 comma plus X. Okay, this is all what we have. This is a big picture. Now I'm going to give you the details. So the big picture is, for memory, we have 4 formats for memory. This is format number 1. So once you see something like that, there is no hashtag here. This means this is a memory location. This is number 1. Number 2, when you see something like that, that means this is one operand. It's a memory location. Is that okay? How can you get the address? I'm going to explain right now. Number 3, once you see something like that, A or B or D, comma X or Y, that means this is a memory location, okay? Number 4, constant, comma X plus or minus before or after, okay? This is also memory location, okay? So memory, we have 4 formats. You see here the 4 formats, okay? Regardless of the format, as I told you for memory, I need address. You should give me address. So how can I get the address? Here, you just simply give me the address. This is the address, right? So how can I get the address here in these cases? Okay, I'm going to explain them. And then I'm going to give you a lot of examples to understand it. So let's explain them, all of them before I give you the details. Okay, look here, guys. So for example, when you have load accumulator A, 1000. So I'm going to read a byte from 1000. So 1000 is here. Okay. So I'm going to read a byte. I'm going to put it in A. Okay, that's easy, right? But when I say load accumulator A, 1 comma X, okay? So here I'm going to read a byte from a memory location. I put it in A. But which memory location? The memory location is actually X plus 1. So I'm going to get whatever in X. I'm going to add 1. And then this will be my address, okay? So here's the address. If you use this format, constant value, so it can be 1 or 0, whatever, any constant value, 0 comma X, 1 comma X, whatever. So here, that means the address, remember, this is a memory, so I need address. That means the address is actually X plus 1 or X plus 0. So X, you just add the constant plus X. Is that okay? This gives you the address. I'm going to give you more details for sure. Very important, and it will be in the quiz tomorrow. I just want to make sure you understand it. This instruction, you guys, does not change X. I'm going to get whatever is stored in X, I'm going to add 1. So this instruction does not change X. Okay? So I'm going to get whatever in X, add 1, and this is my address. I'm not going to increment X. This instruction does not change X. Okay? So this is one instruction. Okay, now you already told us we have another one here, A or B comma X. Yes, we have this one as well. So what is the address? If you say a comma x, so what is the address? Very easy. The address is x plus a. This gives you address. Okay. So I'm gonna, this is register x, this is register a. I'm gonna whatever here, I'm gonna add them, and then this is gonna point at a memory location. That's it. This is your operand. Okay. Again, this instruction should not change. It does not change x or a, right? So in tomorrow's quiz, I just want to make sure you understand this one. So I'm going to tell you, before I execute this instruction, this is the value of x. After I execute this instruction, what is the value of x? I'm going to ask you. Okay. So anyway, so okay, so you told us very simple. If you have something constant, comma x. So in this case, the address is x plus 0, and this one does not change x, right? Also, if you have a comma x, you have something. It's again, this one can be a, can be b, can be d, whatever. So as an example, I just use a for now. So here the address is x plus a. Okay, so you just add the values of the two registers in order to calculate or in order to get the address. Okay, don't worry. I'm going to tell you later. Okay, so why you do this way? I'm going to tell you, but just let's agree on this one first before I give you the details. Okay, so when I say, just give me 1 second. When I finish this one, if you still have any question, I'm going to take it. Just let me finish. Okay, so what I'm saying here, guys, when you use this one, that means you mean the address is a value of x plus 0 or the content of x plus a. Okay. The last one, the third format we have is something like that: 1 comma x plus or 1 comma plus x. Okay, how this one is different from plus? So you can see here you can have 1 comma x. So if you have 1 comma x, guys, that means the address is x plus 1. Yes, that's true. So how this one is different from 1 comma x plus or 1 plus 1 comma plus x? How is this one different? I'm going to tell you. Okay, but for now, you remember in C language, when you did something like that, x should equal I plus plus or x. But so I'm not going to use x because maybe you are going to confuse. Register x, no. Okay, so variable x here, I'm going to use j, for example, or j should equal plus plus I. You remember when we did something like that in C language? They told you in C language, actually, this is 2 instructions, but I put them together, right? This is 2 instructions together, right? Just a compact format, short format. But actually, this one can be replaced by here, j is equal to I. And then I equal I plus 1. Is that okay? Here, this one is I should equal I plus 1, and then j is equal to I. That's what you learn it in C language. So in both cases, I'm gonna do 2 operations in both cases. Number 1, j is equal to I. Number 2, I'm gonna increment I. Is that okay? You can see that's what I did in both cases. Is that okay, guys? So this is like a compact format for doing these 2 instructions. However, if you put this plus plus post, or it can be pre. So if you put plus plus first, it becomes pre. What this means? This means I have to increment first before I put before j is equal to I. So j is going to have the updated value for I after you add. But this one, because it is post, the increment is post. So assignment first and then increment. Is that okay, guys? Is that okay? Exactly same thing. We're going to do it right now. Okay. Again, all what I need from you now is just to understand. I'm going to give you details for sure, but all what you need from me now to understand. When I use this format 0 comma x, how can you calculate the address? So x plus 0, x plus whatever constant there. Or when I have x plus 1 comma x. Same thing here. If I have a comma x. Now, if I have these 2, so this is same thing like this ones? Yes. So what's going to happen here, guys, this one should be 2 operation. So here I'm gonna read a byte pointed by x. So now, so my address is x, and then x should equal x plus 1. So this one is going to increment x. And also the address I'm going to read or write is going to be the value of x. This one, because you increment first, so this one should be x should equal x plus 1. So you increment x first, and then you are going to read the byte pointed by x. So in both cases, I see here, I'm going to do two things. Okay, I'm going to get address. Okay, this is address I'm going to read or write, which is x. In all cases, it's x. Also, I'm going to increment x. The difference between them, are you going to increment first, or you are going to read memory first? Is that okay? I'm going to give you, this is like a big picture. I'm going to give you the details now. Very simple, very clear, very simple. Look here. These instructions don't change x or a. So here, x or the register a do not change. Okay? But these instructions, they change them. So this instruction, this is the only instructions that change register x because it increments x. Okay. Anyway, this is like a big picture, guys. All what you need you to learn from here. If I give you this format, can you know which address? Now I'm going to give you details. Why I make this way? Why I need to increment x? There should be a reason. Yes, there is a reason. Okay. So again, before I give you the details, if you see this format constant comma x, that means the address. That means number one, this is a memory. Yes, your operand is memory. That's number one. Number two, the location in the memory you are going to read or write is actually x plus 1, or in this case is x plus 0. Okay. Here, if you see something like that, a comma x, number one, this is a memory location. Your operand is a memory. You are going to read from memory. You are going to write to memory. Which location? X plus a. This is your address. Okay. And here we don't change x or a, so they should be the same. Here, when you have something like that, here actually we're gonna do two operations. I'm gonna read or write from a location pointed by x, and then I'm gonna increment x. Or I increment x first. So this instruction are gonna change x. Okay. And then I'm gonna read location pointed by x. Okay. Again, let me finish and then I'm gonna take your questions. This is like a big picture. I have a lot of examples here. Okay, guys. So this is the summary I explained. For memory, it can be direct or extended. In this case, you just use a number. Okay, a number for the address. It can be indexed and usually this indexed is used like a point. Indexed means pointer, same thing. And usually this one is used if you want to read or write arrays, right? And here our pointers x and y. So we're going to use registers x and y as pointers here, okay? Like BC, but BC is not BC is a special case. It is only used to read a program, right? X and y are used for your arrays. In your program, you have array and you want to read this array, so we're going to use x and y, okay? So this is the first format I told you about, constant comma x or y. This constant can be 0, can be 1, can be 2, whatever. I told you here, how can you get the address, x plus the constant, a or b. And okay, so also I told you how can you get the address. The address here is actually a plus x, b, and also this one is called auto increment or auto decrement. So I give you example for plus. It's the same thing if it is for minus. Okay, I'm going to give you now details. Okay, that's what I explained last time, guys. When I say, I think I already explained this one. So for example, when I say load accumulator A10, what means it? When you see 10 this way without hashtag, that means this is a memory. That means this is a memory and address is 10. So I'm going to read the byte because this instruction is for a byte. I'm going to read the byte from location 10. So whatever here, I'm going to take it and put it in A, right? However, if you see something like that, hashtag and then 10, that means this is not a memory. This is number 10. So here I'm going to put number 10 in A. Very important, okay? So I think I explained this one last time. So now I want to focus on the new ones, the pointers. Yeah, so now for point. So yeah, so when you see something like that, guys, so I'm going to start with the first one, case one, and you have constant, comma, x and y. Okay, that's what I explained. Okay, I told you in this case, your x is going to be x plus constant. This is going to give you the address. Also, I told you this one does not change X. Does not change X. So let's have example. You can understand better from examples, okay? So the example here, when you see something like that, load register A, 0, X. When you see 0, X, you should understand, number one, this is a memory. Number two, okay, this is one operand. So I'm going to read a byte because this is an instruction for a byte. I'm going to read the byte for my location in memory. Which location? Actually, it's going to be X plus 0. So X plus 0, someone can, you add 0? No, this is just a format. You have a constant, whatever the constant value, I don't care about. Yeah, for sure. If you add 0, it's the same, right? So some students are confused why you add 0. In general, I'm explaining it in general. You have here, you have a constant number, whatever the constant number is. Okay. So here, in order to get the address, guys, as you see here, I'm gonna see what is the value of X. I'm gonna add the constant value, and then this is gonna give me the address. Once I get the address, I'm gonna get a memory. I'm gonna get a byte from there, put it in register A. Until here, any question? Don't ask about the new stuff until here. You have any question here?
I just answered it.
I already answered it. Sorry, I didn't. I'm not hearing.
You did X plus 0. I was confused where it's being stored.
Okay. Okay, guys. So same thing here, guys. When I do some load D 1, X, don't be confused. Once you see constant, X, so this is a memory location. It's a memory location. Okay. And here I'm gonna read the word. I'm gonna read the word because this is instruction for a word. So which memory location? I'm gonna add X plus 1. Right? Again, I'm not gonna change X. I'm gonna ask it in this point tomorrow. This instruction does not change X. Okay, 1, X. The only instruction that changes a pointer when you have auto increment. Yeah. So this instruction don't change the value of the pointers or the value of the register. The only ones that change the pointers when you have auto increment or auto decrement. Okay. So let me. So, okay. Yeah. Okay, guys. So here I'm gonna read the word. Okay. So which memory location? So I'm gonna give you this address, the first address here. Okay, which is X plus 1, right? So, and because this is a word, so I'm gonna get this address and next one, as usually we do that. You give me one address. And because it's a word, I'm gonna get this one and next one as well. So I'm gonna read these two. I'm gonna store them in register D. Any question? Okay. So let's have another example here, and I'm gonna ask about this one tomorrow. So if X is storing number 1000, okay, and then I execute this instruction 1, X. You know what this instruction is gonna do? This instruction, you are going to read the byte because this instruction for a byte. In which memory location? It is 1000 plus 1. So actually, you are going to read the byte at memory location 1001, as you see here. So I'm going to read the byte from the memory location 1001. Okay, I'm going to put it in register A. Okay, so now, after you execute this instruction, what is the value of X? It's still 1000. Okay, so I'm not gonna add. This one is not gonna be added to X. No. Okay, I'm gonna get 1. I'm gonna get X. Add them together. I'm gonna get address, but I'm not gonna change X. Okay, no. So let's look at the second case. If you have, as I said, A, B, or D, comma X or Y. Okay, something like that. When you see something like that, I'm gonna teach later. You should understand. Load register A. B, X. Once you see B, X this way, or A, X, or D, X, once you see something like that, don't be confused. That's a memory. Yes. So I'm going to read the byte from memory, put it in A. Is that okay? Memory. If it is memory, you have to tell me which address. Very easy. I'm going to get the value of X. I'm going to get the value of B. I'm going to add them together, and then I'm going to get address. This is the address, right? So your address should be calculated this way, X plus B. And again, this instruction or this format, X or B will be the same. It does not change X or B, will be the same. Okay, guys? Again, I didn't explain yet why I need to do it B comma X. I'm going to explain why. Okay, or how I'm going to use it to read array. I'm going to explain it. Okay, so look here, guys, what I want to say here. If you have array and I want to read array, how can you do that? Very simple. Look here, I'm going to use X as a pointer. Okay, imagine, look here. Imagine this is like an array. This is 5, 5, 5, 5, 5, 5. Okay, I want to read this array. So number one, I have to initialize X with the beginning address of the array. Okay, so I have to see what is the beginning address of the array, and I have to put it in register X. So now X is pointing at the first location, this number, initialization. Okay? So now, and then I'm gonna read the byte pointed by X. So I got the first element. Now I'm gonna increment X. Is that okay? Read the next one. Increment X. Read next one. Increment X. Increment X. You can do this way. Okay? Or I'm not gonna increment X. You know what I'm gonna do? 0, X. It's gonna give me this guy. 1, X, 2, X, 3, X, 4, X. You got what I'm saying? Because 1, X, I'm gonna add 1 to X. So X is pointing at the first one. When you add 1, it will be here. When you add 0, I'm here. Because again, it's just another way to do it. That's what I'm explaining here. Another way. If X is pointing at the first location in the array, so 0, X is going to give you the address of element number 0. 1, X is going to give you the address of element number 1. Okay, here I start counting from 0. It's not a big deal. 2, X, so we're going to add X plus 2. Now you start to understand why I put constant, X. Because X is going to point at the first location, and then when I add a number, I can go through the array. You got what I'm saying? So if I add 0, I'm going to get element 0. If I add 1, I'm going to get element 1, and so on. But in this way, I'm not going to change X. X is always pointing at the beginning, and then I add a number so that I can get all the elements in the array. Is that okay? This one way. I can do it in different ways, but this one way. Any questions? So now you should understand why we have this format: 1, X, 2, X, 3, X, 4, X. Why we have it? Okay, in order to read the array this way. Any questions? I'm going to ask a question as long as you don't ask me questions. Okay. Now assume here this is array of bytes. If this is array of words, how this would it change? If it is array of words, yeah. Yeah, so you have to add 2, not 1. That's true. Because here, X is pointing here. Okay. And next, so here you add 0. Here you have to add 1 to be here, right? But these together are one element. And here you have to add 2. Okay. That means when I read the first byte, it's going to be 0, X. The first word, sorry. If you want to read the second element, so it has to be 2, X. So every time you have to add 2, right? Because addresses are going to be added by 2. Is that okay, guys? So again, in this example, if it is array of bytes, you just add 1. You start from 0, X, and then you add 1. Yeah, makes sense, right? If it is array of words, you would add 2. You have to add 2. Is that okay? Because every time you read, I'm going to read 2 bytes, so you have to add 2. Is that clear, guys? Any questions? Okay, so here in this case, element 0 should be 0, X. If it is array of words, this is array of bytes. Here it should be 2, X. Here should be 4, X, and so on. Is that okay? So, okay, now I can do the same thing using this format. Okay, again, I'm going to read array by different ways. I'm just explaining different ways. Okay, so here I'm going to do it in a different way. Look how I'm going to do it. Now, X, I told you when you have b comma x, so what is the address? The address is actually x plus b. Look at the idea. Now, x is going to point at the first location. So x is pointing here. Is that okay? And then you add b, you add register b, right? That means, so here it's x. Yeah, so x plus b, right? X, that means if I put 0 in register b, I'm going to get element 0. If I put 1 in register b, I'm going to get element 1, and so on. Okay, guys? So here, again, this is just another approach to do it. X is going to be, I'm not going to change x. X is pointing at the first location. The address is actually x plus b. All what I'm going to do, I'm going to just play, or I'm going to change b, right? So if you put number 0 in b, so my address is going to be x plus 0. So the address here in this case, the address is going to be x plus 0, which is x. So that's why I'm going to get here the first element. If you want to get the second element, you have to put 1 in register b. In this case, should be x plus 1, okay, which is going to be the second element, right? Here, if I want to read location, if I want to read element number 10, very simple. So I'm going to put 10 in b, so that that's going to be address x plus 10, and so. Is that okay, guys? Again, this idea is exactly similar to this one, exactly similar. The only difference is, instead of putting a constant number here, this number will be in register A or register B. That's it. Okay, guys, any questions? So if you want to use this approach to read an array, all what you have to do is, number 1, initialization. Register X is here, register X is here, okay? And then B is equal to 0. B comma X, I'm going to get this guy, right? Increment B. Now B is 1 comma X, you can increment this guy. Increment B. Now B is 2. X plus 2 is here, and so. So every time you want to read element, you can increment B. You don't need to read them in sequence. I'm saying if you want to read all the array. For example, if I want to read location number 100, so just put 100 in B. It's going to be X plus 100. Is that what I'm saying? So again, this is just a second approach. Any questions? Okay, I just have an example here. So for example, org 1000 buffer. This is just the name of array, and that's what you are going to have in tomorrow's lab. Buffer dc.b 3725. So I have array, as I explained before. This array has how many elements here? 1, 2, 3, 4. Okay, 1, 2, 3, 4. 1, 2, 3, 4. As you see, and this array started from location 1000. Very important. I told you the beginning address. Very important, the beginning address, because all the time I have to put the beginning address in register X. You know what I'm saying? How can you do that? First of all, let's see. If I want to read this array, how can I read it? Yeah, there are different ways. One way to read this array, I can do something like that. I can say load register A 1000. So I'm going to read a byte. Then I can say 1001, 1002, 1003. Yes, I can do this way, right? However, this way doesn't work all the time, as you'll see later. If the array is too big, if I want to read array of 100, 200 elements, I'm not going to write 200 lines or 200 comments, as you'll see later. Yeah, you can read the array this way if you want. Another way, I can say X should point at the first location. So I can say load X hashtag 1000. So what this means? Very simple. Hashtag means it is not memory. It's number 1000. Is that okay, guys? So here I'm gonna store number 1000 in register X. This is how I initialize register X. Is that okay, guys? Okay. Now, okay, but here it may be easy to know the location, the beginning, the first address of this array. It's easy to know because this array just came right after org. Okay. What if, for example, you have here org 1000, and then you have some definition, dc.b, ds.b, whatever, and then I put buffer here. how I can get the beginning address of this one? Should I calculate? I start from 1000. This one takes 2 bytes. This one takes 4 bytes. This one, should I calculate? No, you don't need to do that. If you remember last lecture, I told you in your program, and this was a question in the quiz, in your program, when you use the name of the array, so when I use the word buffer, this is the name of this array. If I use it in my program, the assembler is going to replace it by the beginning address. You got what I'm saying? So I don't need to bother myself, or I don't need to search or to calculate where is the beginning address. You don't need to do that. You know what we are going to do? What we are going to do is, I'm going to say load x hashtag buffer. That's it. Always students are confused when they see this instruction. They don't like it, okay? However, if I say load x hashtag 1000, they are okay with this one. They understand this one. So I'm going to write 1000 here. They are okay, right? But when I do this one, they don't understand it. They're the same. They're the same. All what's going to happen, the assembler is going to remove the word buffer and is going to put what the beginning address. 1000, 2000, whatever it is, okay, whatever the location. So it's gonna just put a number here. So don't be confused, guys. When you see first hashtag means it's not memory, it's a number. Okay, when you put here buffer, so you actually it's gonna be replaced by the beginning address. Is that okay, guys? All the time we'll do something like that. If you have array and you wanna read array, as I said, the first step, you have to initialize the pointer at the beginning address. How can you do that? You are going to use this instruction. All the time we'll do that. Is that okay? Number one, you have to initialize x to the beginning address using this instruction. Okay? You don't need to worry about it. Where is the beginning address? Just write the name, and this name is going to be replaced by the address. Is that okay? Anyway, so again, this is what I did here. So here I put 1000, but for sure it's better just remove it and just put buffer. Yeah, it's better. You don't need to worry about where is the location. Just write the name, and this one, the name is going to be replaced by the beginning address. Okay. So now I initialize x this way, and then I can 0, x is going to give me one element. 1, x can give me another element. 2, x is going to give me another element. 3, x is going to give me another element, and so on. So if I want to read this array, this is one way you can do it this way, or you can do this way. Is that okay? Again, different ways, but again, as you will see right now, this may not be the best way to do this way, especially if the array is too long, as you will see right now. Okay. Any questions? Okay. So I think in tomorrow's lab, and I think also in the quiz, maybe the quiz, I just want to make sure you understand what is the difference between when I say load register D and then I put here buffer, or load register D hashtag buffer. What is the difference? Okay. Again, don't be confused yourself. Okay. Buffer, the word buffer is going to be replaced by the address. That's it. So just as I am showing it here. So buffer is going to be replaced by the beginning address, which is 1000. This one is replaced by 1000. That's it. Okay. So now you know this instruction. You read the word here. You also a word, right? Again, because we have a hashtag here. That means this instruction it's not memory. Hashtag, it's not memory. So this instruction is gonna store 1000 in register D. Yes. But this instruction here, you are gonna read a word. This is a memory. So you are gonna read the word from location 1000 and 1001, and then store it in register D. Okay, guys, very important to understand this. Again, what is the difference between when I say, okay, let me remove this one. When I say load D buffer, load D hashtag buffer, what is the difference? The difference is here, Buffer is going to be replaced in both cases. Buffer is going to be replaced by address anyway, the beginning address. In this case, the beginning, this is not memory. I'm going to put the beginning address in D. But in this case, I'm going to read the word from the location 1000. I'm going to put it in D. So if you go to here, if you read the word here, it's going to be 3 and 7. So I'm going to read this word. I put it in register D. That's what I did here. Okay. This is in tomorrow's lab. I'm going to ask you a question. I just want to make sure you understand two things here. Number one, buffer is going to be replaced by the beginning address. This is number one. Number two, here you copy a number. Here you copy a word at memory location. Is that okay? Anyway, now, okay, I just told you if you have array, you can read the elements of the array this way, or you can do this way. Yes, you can do that. However, if the array is too long, for sure you can. It's not efficient to do that. If you have 1000 elements in the array, 1000 elements, so it means I'm gonna write 1000 instruction. For sure, we don't do that, right? That's why they invented loops. That's why loops were invented. So we have loops so that you write it only in one time and then you can loop instead of keep writing the instruction many times. Okay. So what if you have a big array? How can you read this array? I'm going to show you right now how can we do it. You have array. This array called buffer. So number one, I'm going to initialize register X with the beginning address. This is number one. So after this instruction, X is pointing at the first location. Is that okay? We agree on that? After this instruction is actually initialize X with the beginning address of the array. Always we will do that. Okay, this is number one. Okay. Number two, look here how I'm gonna make a loop. I'm gonna read the byte. Look at this instruction here, guys. I'm gonna read the byte pointed by X plus 0. So I'm gonna read the byte pointed by X. Is that okay? Then I'm gonna increment X. This is the instruction, it's gonna increment X. Then I'm gonna loop back. You got what I'm saying? So that's how they invented loop. So the idea is simply, number one, initialize X is here. This number one. So in the first iteration, I'm going to read the byte pointed by X. So in one iteration, in every iteration, I'm going to read one element. I'm going to work with one element. And then I'm going to increment X. So in iteration number 2, X is here. So I'm going to read this guy, right? I'm going to use it. Iteration number 3, I'm going to increment X. Iteration number 4, increment X. Okay? So by this way, you can read the whole array. Okay? But for sure, if the array is long, I have to do this way, loop. Is that okay, guys? Okay. Any questions? So here, for sure, I'm going to teach you this. I didn't teach you instructions yet, but I just give you some instructions that can help me to teach this topic. So here, increment X. This one is going to increment, and then I'm going to loop back. So I'm going to keep looping this way. Every iteration, I'm going to work X on one element. Okay, so every iteration. So in the first iteration, X is here. Next iteration, X is here. X is here. X is here. Is that okay? Any question? Okay, guys. Similar to PC, the only difference is PC, because the instruction are not the same size. Some instruction 2 bytes, 3 bytes. Here X is going to be every time incremented by 1, because all the elements have the same size, bytes. But in case of PC, one time it's incremented by 2, one time it's incremented by 3. It depends on the size of the instruction. It's the same idea. Any questions? Okay. Now, another idea, guys. Here, I can do it in a different way. I just want to show you B, X. How can you use B, X, A, X? How can you use it to read an array? Someone can tell me, can I use this one all the time? For sure, you can use this one all the time. But again, when I teach programming, I have to teach different approaches. Okay, you may not need all of them, but I have to teach different approaches, and you may use all of them. Okay, so don't think. So what is the difference between this one and this other one? No, there's no difference, right? So both of them can be used. Okay. So anyway, I'm gonna read array in a different way. Here I'm gonna do something different. So what I'm gonna do here, guys, is tell X. I'm going to initialize X as you see here. So X is pointing at the first location. Is that okay? And then here because I'm using b comma x. So the address is actually x plus b. This is the address, x plus b. Here, I'm not going to change x. So I'm not going to increment x. X is going to be fixed. What's going to happen? X plus b. X should point at the first location or first address, right? B, in every iteration, I'm going to change b. So here, if b is 0, so now first address plus 0, I'm going to get element 0. In iteration number 2, now is b is 1. So every iteration, I'm going to increment b. You got what I'm saying? It's like I have x, and then I'm going to shift x by b, right? But I'm not going to change x. So as you see here, guys, in the very beginning, I'm going to clear b. So b is 0. And then I'm going to read byte pointed by x plus b. I don't change x. X is fixed. X is always pointing at the first location. All what I'm going to change b. So in every iteration, as you see here, I increment b. And then I loop back, increment b, loop back, increment b, and so. Is that clear? Just another approach. Yes.
Does the loop stop automatically?
That's a very good question. Okay. Here, I'm not teaching loops here. Okay. I'm just teaching how can you read arrays. Is that okay? The way I did it here, this is going to be infinite loop. Is that right? Infinite loop. Because it is later when I teach it, I'm going to put a condition. You can put a condition. If the number of elements in the array are 100, you can put a condition. Once b is equal to 99 or 100, just leave, go outside. Got what I'm saying? So you should not worry about this for now. I'm not teaching loops yet. Okay. Okay. Now, guys. Now, the last thing I want to teach right now is what if this auto increment boost. I know this is a little bit confusing to students. Okay, so I'm trying my best to make it very easy. So, as I told you before, guys, in C language, you did something like that in C language. Y should equal x plus plus, or y should equal plus plus x. You did something like that. And in C language, as I told you, this one is actually 2 instructions, right? You increment x, also you assign x to y, or you make assignment, right? But which one has to be done first? It depends on the order. So if you do plus plus first, as you see here, so actually you increment x first, and then you do the assignment. So that's why this one is called pre. In English, the word pre means first, comes first, right? This one is post, right? Because the increment is pre. This one is the increment is post. Okay, same thing here. We're gonna do the same thing here. Okay, so what we're gonna do here, guys, look here. Okay, let me go back here to tell you. You know what I'm gonna do right now? I'm gonna tell you. Look here. See, try to see what I did here, guys. What I did here, number 1, I'm gonna read element pointed by x. This number 1. Number 2, I'm gonna increment x. In every iteration, I have to do 2 things. I read element pointed by x and then increment x. Is that right? So what I'm gonna do right now is, and instead of writing two separate instructions to do that, I'm gonna merge them. I'm gonna do it using only 1 instruction. You get what I'm saying? So here I have to write 2 instructions. 1 instruction to read location pointed by x, and then I have to increment x. So I write 2. Now I'm gonna do the same thing, but just using 1 instruction. Okay. Someone can ask me, can I use this one all the time? Sure, you can use this one all the time, right? You may not need to use the other one. Yes. Okay, you can do that. I'm totally fine. However, I'm expecting that you understand it, so that when I put it in the slides, so when I give it to the quiz, you understand it. Okay, and even maybe in the beginning a little bit difficult, but once you get familiar with it, you are gonna like it. You know why? Because it's gonna just shorter format, or you can. So here, guys, when I say, yeah, I think I put all of them here. Look here, guys. So if I put 1 comma x and then plus here. Remember, when you have 1 comma x plus here or here, actually you are doing two instructions. You actually reading location pointed by x, and also you increment x. You are doing 2 things. Okay, you increment x, and then you are going to read location pointed by x. 2 things. Okay. However, the order, which one should be done first, should be determined by the location of this plus. If the plus is here, so I have to increment first. Okay, and then I'm going to read the location pointed by x after you increment. Is that okay? So I'm going to show you now, if you have array and I want to read array, so I can do this way. Look here, guys. If I say load register A 1 comma X plus, very important. Look here. You know, this instruction is actually equivalent to 2 instructions. This instruction is equivalent to 2 instructions. Number 1, because this is post increment, post, not pre, post increment. That means I'm gonna read the byte pointed by X first, as you see here, guys, and then I'm gonna increment X, right? But if it is pre, as you see here, if it is pre, so what's gonna happen here? Let me take this one down. If it is pre, as you see here, guys, plus first. So I'm gonna increment first, and then I'm gonna read the byte, the byte element pointed by X after you increment. Is that okay? So tell me, if you have an array and I wanna read this array, how I can do it? I'm gonna tell you how. Look here, guys. X should point at the first location, as you see here. X is pointing at the first location, and then what? When I use this instruction is gonna read one element and then increment X. Is that okay? So in the very beginning, if use post, so X is here. If use post, so I'm gonna read and then increment. Is that right? If you want to use pre, for some reason, I'm not saying one of them can replace all of them. I'm totally fine, but I'm saying if you want to use pre, so what you have to do, X should be pointed at one location before. It's not at the first location, it should be one location before. Why? Because I'm going to increment and read. Increment and read, because you increment first. Again, I'm not saying you have to do this way. I'm saying if you want to use it, okay, so you have to do this way. So as you see here, X is pointing at one byte before. Okay, guys, because this one is going to increment, read, okay? Again, we can do the same thing. Instead of increment, you can decrement. Decrement. By using negative here or minus, you can actually decrement. How can you use it? Again, I don't think we are going to use it much, but just in case, here, if you have array, in this case, X should not point at the first location, X should be at the last location. Because every time you increment, so you're going to go from here to here. You understand what I'm saying? Again, I don't think we're going to use it, but the idea is that X should point at the last location and then read, decrement, read, decrement, read, decrement. Okay? Because that's how it works. Any question, guys? So tomorrow, I'm expecting that you understand if you see something like that, 1 comma X plus before or after, okay? Post or pre. You understand this one should do 2 things, should increment X. This is the only instruction that changes X. The other formats I explained, they don't change X. That's why tomorrow in the quiz, I'm gonna give you X, I'm gonna give you the value of X before this instruction. And then after this instruction, I'm gonna ask you what is the value of X, okay? Again, I'm repeating it here. If you have load A 1 comma X, so here I'm gonna read the byte at the location pointed by X plus 1, put it in A. But this one does not change X. Okay. Here, this one should change X. So here I'm gonna read the location pointed by X, then I'm gonna increment X. Is that okay? Yes, sure.
Can you increment by more than one? Just put like 2 comma.
That's very good question. Okay, you have to do that. When you have to do that? Yes, you have to do that. But when? I want to hear from you. Yes. So what I'm doing right now, it's 1 comma X plus. Someone is asking me, sometimes do I need to do 2 comma X plus? My answer, yes. When? When it is array of words. That's true. When it is array of words. Right? So I'm gonna read the word, the point by X, and then I'm gonna increment X by 2. That's true. Okay, guys? Any questions? Okay. I just have more examples here. When I have, yeah, that's what I'm saying here actually. don't be, I don't want to use X here because you will be confused. If you have something like that, load D 2 comma X plus. What this instruction is gonna do, this instruction is gonna, I'm gonna use something. I'm gonna read a word pointed by X, okay? And then I'm gonna increment X by 2. Yes, you have to do that when it is array of words, yes. Okay. Any question, guys? Okay. This topic is important. I know it's a little bit confusing, so please do your best. We are going to use it for sure. I'm going to use it all the time. So all the time we're going to use this. This topic is called addressing modes. Addressing modes. Let me, before I take this question, I wanna. Because every addressing mode I taught right now, it has a name. I just want to choose the name because in tomorrow's lab, I'm going to use the name, okay? So I want you to be familiar with the names. Yeah, so here, guys, indexed mode, okay? We have indexed with constant offset. This is 0, X, 4, X, and so on. So you have to be familiar with this name, indexed with constant offset, okay? The other one is called indexed with an accumulator register offset. By the way, the word accumulator, when I say accumulator, I mean register A or B or D. So this register, we call them accumulator, okay? So when I say indexed with an accumulator, I mean indexed means X or Y, accumulator means A or B or D, okay? The third one here is called indexed with auto pre or post increment or decrement indexed register. Okay, guys? Just you should be familiar with these names because we are going to use these names tomorrow in the lab. Yes, any question here? Okay. So tomorrow's lab, it's a very short lab for sure because I divided it into 2. That's why tomorrow, in the first part of the lab, I'm going to teach a lecture because I need to speed up a little bit because the way it is, what we have right now is not good because I have lecture on Wednesday and then I have lab on Thursday. Okay, so you don't have enough time. So I have to speed up in the lecture so that you have enough time to do the lab. I hate that I teach a topic today and then you're going to have a quiz tomorrow or you have a lab tomorrow. I hate it, but that's what because that's how we have right now. So I'm going to try to change it, but I'm going to give a lecture tomorrow so that the topic I'm going to teach tomorrow, okay, is going to be the lab for next week. So you're going to have a week to study, week for quiz, okay? It's going to be much better, okay? That's why, and also the lab is short lab. So I'm going to teach a lecture for 1 hour or 1 hour 15, no more than that, okay? And then we're gonna have a lab. So tomorrow lab is actually about this addressing modes. So and quiz tomorrow will be something like that. The quiz tomorrow, you know, every Thursday we have a quiz. We agreed on that, okay? So the quiz tomorrow it's gonna be something like that. For example, I'm gonna give you an instruction like this one, and then I'm gonna tell you. Okay, so I'm gonna tell you here, load register A and then number 10. Okay, what if you execute this instruction? I'm gonna test you in the addressing mode. I want to make sure you understand when we have a hashtag here, so you are gonna have number 10. Okay, same thing here. I want to make sure you understand here. You have to read a byte, and this is address. So you're gonna go to location 2000. You are gonna get whatever there, put it in A. Same thing here, guys. This is here, you are going to read the word, load Y for a word. By the way, because you have, I'm going to teach very soon. Tomorrow, I'm going to teach it, but quickly, we have load register A. So this one is going to read the byte, put it in register A. We have load B. So this is going to read the byte, put it in B. We have load X. We have load Y. We have load register D. These 3, you are gonna read the word, you are gonna put it in X or Y or D. Okay, what you are reading here, this can be memory or it can be immediate value. So here in this case, This is a memory. I'm going to read the byte from a memory. This is immediate value. I'm going to put it in A. Okay. So here, because this is load Y, so here you actually it's going to read the word from the location 2000. So here I'm going to take these two. I'm going to put them in Y. So the quiz tomorrow, I'm going to give you picture like this one. Also, I'm going to give you this instruction like this one. Then I'm going to ask you to fill up here, this one's here. So I'm going to tell you what is in A after you execute this instruction. I just want to make sure you understand the addressing modes, okay? I want to make sure you understand this is memory. So the value of A has to come from here, right? This is also memory, but this is for a word. So I'm going to take these two, I'm going to put them here. I want to make sure you understand when I say 10, x, you understand what this means, 10, x. So here, it means I'm going to read the byte from the location x plus 10, as we agreed. So if x of x is 1000, so the location should be 1000 A. Because 10 here is decimal, which is hexadecimal A. So I'm going to take this, I'm going to read this one value here. Is that okay? So x plus whatever the number here, x plus this number, x. If x is 1000 plus 10, so it's going to be this location. Is that okay, guys? Any question? Yes, sure.
Should we put dollars on?
Where? Here? Sorry, where? You have to put the dollar sign if it is hexadecimal. Maybe I made, yeah, maybe here I made a mistake because this one is hexadecimal, so I have to put dollar sign. Yes, if it is hexadecimal, you have to put dollar sign. That's true, right? If it is decimal here, because this number is decimal, I want to add number 10, right? That's why it's decimal number. That's why I didn't put decimal dollar sign. The other thing I want to explain here is okay, guys, so this will be tomorrow's quiz. It will be something like that. Also, I want to tell you here, if you go to the instruction set, I almost explained everything in the instruction set except only one thing here. Look here, guys. For this instruction set, I explained everything here except only one, yeah, here. So can you see here, guys? Addressing mode. So here, this one is telling, this column should tell what kind of addressing mode you can use with this instruction. Is that okay? So what do you mean by addressing mode? I already explained addressing modes. Number one, it can be inherent, right? It can be immediate. So IMM here means it is immediate value. So it's already written here somewhere. So you will find IMM means immediate value. Yeah, look here. Immediate value. DI means the directed addressing mode, okay, and so on. So here, using this column, you can know what kind of addressing mode you can use with this instruction. There is one addressing mode I want to teach right now. It's called inherent. So I'm going to tell you what I mean by inherent. Okay. So this again, so this column can tell you what kind of addressing mode you can use with this instruction. You can use some instruction, as you will see later in this course, like for example, transfer. Here, there should be a register, comma register, right? It's not allowed to use memory location. It's not allowed to use immediate value. It has to be register, comma register. Is that okay? So I'm going to teach them, but they already summarized in the table, in the instruction set table. That's what I want to say. Okay. So here you can get the register. Another one addressing mode, we call it inherent. Inherent. You can tell from the English name what inherent means. I'm going to tell you. Look here, guys. Inherent means, again, for any instruction, like for example, transfer. So TFR means transfer. And to transfer here means copy. You want to copy, register to register. Okay. transfer, and then you put operand here. So in this some instruction, actually you don't need to put anything next to the instruction itself. Like for example, increment x. This is one piece. This one instruction, increment x. You got what I'm saying? So the operation and the operand are together, right? Like increment x. So in this kind of instruction, I don't need to write anything here. You got what I'm saying? It's different from transfer. Transfer, you are gonna copy register to register. So you have to tell me which register. So some instructions I'm gonna teach, I'm gonna call them inherent. So inherent means the operation and the operands are together. That's why you should not write anything next to it, right? So we have some of this instruction. We have like clear A. This one is clear register A. Clear means 0. You put 0. Or clear B. You don't need to write anything next to it because the operation, the operands are just together. That's what we call inherent. Is that okay, guys? Any questions? Okay. So actually, look here, guys. Any instruction should have one of these format. Any instruction I'm going to teach should have one of these format. Some instruction only have opcode, only opcode, like increment x. We agree. Any instruction, it has to tell, number one, what is the operation? Number two, where is the source of the data? Where is the destination? Where I have to store the result. Is that right? So some instruction is called inherent, as I told you, right? So in this one, you have only opcode, like increment x, like clear B. That means you don't need to write operand next to it. You don't need, because already everything is in the opcode. Okay. So the instruction I'm gonna teach you guys, we have these 4 formats. Sometimes we need only opcode. Sometimes you need opcode and then you put here one operand. Sometimes you need opcode and you have to put operand, comma, another operand. And very few instructions, you need opcode and then you have to write 3 operands this way. Okay, guys? So for sure, when I teach this instruction, I'm going to tell you if this instruction, should you put operand here or not, okay? Here, some instruction, by the way, most of the instructions are here. Most of the instructions are this way, okay? You need only to give me one operand because usually there is another operand already in the opcode itself. For example, when I say load A and then number 10. So you need to give me one operand because the second one, the destination is already here in the code itself. You got what I'm saying? So you need only to give me one. Anyway, the conclusion, I don't want to confuse you. You will see right now, when I teach an instruction, some instruction, you don't need to write any operand because it's already there here. In any case, the instruction should have, okay, is a operation and also the data, where the data has to come from. Okay, but what I'm saying, sometimes I don't need to put the operand here because it's already here. That's what I'm going to say. So some instruction, you don't need to write anything like increment x. Some instruction, you have to write only one operand. Some instruction, you have to write 2, right? Some instruction, you have to write 3. But most of the instruction I'm going to teach are this one. Okay, so you will see. So here, what I'm going to do right now, guys, I'm going to start teaching. I'm going to start to teaching assembly. I didn't teach in assembly. I already explained a couple of instructions just to understand the addressing modes. So here in this chapter, so in this section, I divide the instruction this way. In this section, I'm gonna explain data transfer instruction. In this section, I'm gonna explain arithmetic instruction. How can you do branches and loops? How can you do shift and rotate operation? How can you do logic operation and so on? So I divide it this way. Okay. So I'm going to start with this one, data transfer instructions. I'm going to start it now, and tomorrow I'm going to finish it. It's very easy, and I already covered most of them, like load, like transfer, and so on. Okay. So let's start with data transfer instruction. What do you mean by data transfer instruction? What this means? I'm going to tell you what it means. Look here, guys. In C language, we used to do something like that in C language. I is equal to 2. I is equal to J. We did that in C language, right? Or any programming language. I here, okay, how can you do something like that in assembly? Do you have in assembly Can we use equal? No, assembly doesn't have equal. Assembly does not, we don't have equal in assembly. Is that okay, guys? So instead of equal, you have to use an instruction to do equal. So equal is using an instruction like load A with number 10, as I explained before, right? So this one is equivalent to A is equal to 10. Yes. Okay, guys? So you have to use an instruction to do that. This instruction, we call them data transfer instruction. So data transfer instruction means I need the instructions that can do some equal, okay? And same thing here, look here, guys. So what this instruction is gonna do, this one is gonna copy number 2 in I, right? So after you execute the instruction, I should equal to 2. So what happened to the old value of I? It's gone, right? So before this instruction, if I is storing 20, so after you execute this instruction, now I is 2. The old value is gone, right? You override I. Same thing here, okay? I is equal to J. What's gonna happen to this? I'm gonna copy J to I, right? So this instruction J is not gonna change, but I is gonna change. Is that okay? We're gonna do the same thing here, but we're not gonna use equal. We're gonna use an instruction. Also, I and J I'm using here, they can be memory, also it can be registers as well. Okay. So let's have the first instruction. The first instruction. I have a very nice summary, nice picture here. Let me show the picture. Very easy picture. Look here, guys. Very easy. Look here. If you wanna copy memory location or immediate value to a register, you have to use load. So load if is used, you are gonna use load if you wanna copy a memory location or immediate value. Immediate value. Okay. A store, you have to use a store instruction if you wanna copy register to memory location. If I want to copy memory location to memory location, you have to use move instruction, right? If you want to copy register to register, you have to use transfer instruction. Okay. I know it's a little bit confusing here because when I say move here again, guys, move, transfer, it means they mean copy. So you are not going to change the source. Okay. So because move means I'm going to change the source. That's the meaning of move. But here, no, move here means copy. You are going to copy the source. That means if you move this byte to this byte, I actually copy this byte. So this one is 20. So this one should be 20, and so you copy. That's all what we have. So this is all the data transfer instruction. Okay, this is like a big picture. I'm going to explain that tomorrow. So all what we have, guys, now. Load instruction is used if you want to copy immediate value or memory location to one of the registers. Store, if you want to copy register, okay, to a memory, you have to use a store. Move, memory to memory. Move is only used for when you copy memory to memory, byte to byte, or word to word, memory to memory. Okay. Transfer is used if you want to copy register to register. Is that okay, guys? I'm going to give you details tomorrow. And next lab is going to be about data transfer instructions. Okay. Again, guys, please, the addressing modes are a little bit confusing. This is a very important topic, addressing mode. So when you see 0, x, what it means, okay? When you see number 1000, what it means. Okay? It's very important because I'm going to use it all the time. We're going to have tomorrow a quiz, lecture. Okay, and also we're going to have a lab. The lab is very short because it's a half lab. Okay, thanks, guys. See you.